Beautiful people, and welcome. In this video, we're dealing with finite arithmetic series. In part one, I went through some of the equations that you're supposed to know, sigma summation, notation, and then we did do one example. So if you haven't watched part one, go ahead and do that now. In this video, we're going to focus on a few more examples, and then that is it. All right, beautiful people, disclaimer time. If I make a mistake, I am human. Let me know where the mistake occurs so that way I may learn from it. Make sure that you have your formulas in front of you. Here are mine, so I'm going to make sure I have that off to the side. And let's start with example number 2. Find the first 3 terms of an arithmetic series in which a sub 1 is 9, a sub n is 105, s sub n is 741. So what is our whole point? We want the first 3 terms of an arithmetic series. So we know, okay, this is what we know, that we have added up some sort of number that is finite, and that's equal to s sub n. We don't know much, right? We truly don't know much. All we know is that we took a bunch of different numbers, we added them up together, and they ended up giving us a summation. So they do give us a little bit of information, so let's plug that in. They did tell us that the number in the first position is 9. They did tell us that the last number in the nth position is 105. And they did tell us that s sub n is 741. So I'm going to rewrite that. So this is what they told us. They told us 9 plus something, plus I don't know how many more, because they didn't tell us what n is. We don't know how many more. But I know that my last term is going to be 105, and all of that equal to 741. And what they want to know is they want to know the first 3 of them. So here's a sub 1, here's a sub 2, a sub 3. They want to know what those 3 first terms are that we ended up adding all together to get 741. Now, it's not these 3 adding up to 741. It's everything, and we don't know how many terms there are. They didn't tell us. So we have to figure stuff out. All right. First thing I'm going to do is I'm going to go back to my cheat sheet and look at my formulas. They're going to be important. I'm going to write out the formula, and the one in green is going to be the one the majority of time that you're going to use. So I'm going to write that one out. I have s sub n is equal to nt divided by 2 times a sub 1 plus a sub n. That's my formula. If I need to use the other one highlighted in yellow, I'll go back and change it. It's the same thing. All right, so s sub n, they did tell us what s sub n is, and that is 741. They did tell us, they did not tell us how many terms we're adding. So we don't know how many terms we're adding, but I do know it's divided by 2. They did tell us what a sub 1 is. A sub 1 is 9. And they did tell us what a sub n is. A sub n is 105. So I'm doing a happy dance. Believe it or not, I am very happy with this because I only have one unknown. I just don't know what the total number of terms are. I don't know what that is, but that's the only thing that I don't know in this equation. So we're just solving. All right, let's do this. 105 plus 9, that's 114. Make sure that you are following PEMDAS. I'm going to divide both sides by 114 because I am multiplying by 114. So I'm doing 741 divided by 114. And that gives me 13 halves, which is equal to n divided by 2. I'm going to multiply by 2 both sides. 13 times 2 divided by 2. That means my total number of terms are 13. So I know that my total number of terms is 13. That means that this a sub n is now a sub 13. How do I know that? Because I know that my total number of terms is 13. So if this is 1 and my last one is a sub n is now a13, which also means I now know that my s sub n is now s sub 13 as well. How does this help us? Well, does it really help us? I don't know. We'll take a look. We want to know what the first 3 terms are. I still don't know what my common ratio is because it would be really easy if I could just add something to it. But I do know that my last term is 13. So I'm thinking we have to do something with arithmetic sequences and going back to that formula there. I'm going to do a thinking bubble here. I'm a little short on space. That's okay. We'll see what we can do. Alrighty. Let's go ahead and there it goes. I have a sub n is equal to a sub 1 plus n minus 1 times d. That's my sequence formula. I know that a sub n is 105. A sub 1, I know that is 9. Plus, I now know that n is 13. Let me highlight that. I now know that n is 13. And that will allow me to find my common difference. So I have 105 is equal to 9 plus 12d. I'm going to subtract 105 and 9. So I get 96 is equal to 12d divided by 12. My common difference is 8. And at this point, doing very much happy dances because that means I can add 8 to my first term and my second term to find out what the missing terms are. So 9 plus 8, that is 17. 17 plus 8, that is 25. So the question is, what are the first 3 terms of an arithmetic series? And here they are. Term number 1, term number 2, term number 3. All right, let's move on to example number 2. Oh, just kidding. This is example number 3. Example number 1 was done in the previous part 1 video. All right, find the sum of the first 100 positive integers. Okay, so now we have to, if you don't know, Google it. An integer is a positive number. It is a positive whole number, meaning 1, 2, 3, 4, 5, 6, 7, 8, etc. So integers is 1, 2, 3, blah, blah, blah. And we want to find the first 100. So that means my last term that I'm going to be adding is 100. So I have a sub 1 in the first position, second position, third position. This will be in my 100th position. So how can I find out the total? Well, let's go back to our formula, and our formula is the summation of n, or not of n, summation sub n. So s sub n is equal to the total number of terms divided by 2 times the first term plus the last term. So we want to find the total of adding the first 100 integers, positive. Then we want to know what the total number of terms are. Well, the total number of terms are 100. Then we need to divide by 2. The first term we have is 1. The last term we have is 100. And again, doing happy dance because this is pretty much done. 100 divided by 2 is 50. This is 101. 101 plus 50, that is 151. Oh, I added. You guys need to stop. You need to start yelling at me in the screen. That should be multiplication. This is 50 times 101. I thought it was a small number. This is, let's see if I can save it. This is 5,050. 5,050 is the summation of the first positive integers. And let's do one more example. This one is using the summation. Okay. This is your upper limit. This is your lower limit. This is your formula. Use your formula cheat sheet. Always have that for explicit, for recursive, for geometric, for arithmetic. You have that there. Create one sheet of paper to have all of your formulas, because you're supposed to find the summation, right? You're supposed to find the sum of numbers between 1 and 75 using this formula. How do you do that? Well, let's see here. Here's our formula again. S sub n is equal to nt divided by 2 times, I'm using that little dot now since I made that mistake in the previous example. Okay, this is what we're doing. We want to find S sub n, but what is n? This is where in the beginning of part 1, we need to find out the quantity of terms, total number of terms. How many actual numbers are we adding together? Not the what are the numbers? Not where do they start, where they end? How many of them? So you're taking your upper minus your lower limits, and then you're taking whatever that is, you're adding 1 to that. That then equals your total number. So my upper limit is 75. My lower limit is 1. So I have 75 minus 1, that is 74, plus 1 is 75. It just so happened in this example, because my lower limit was 1, that I still remained 75 terms that I'm adding, because I started with position number 1. It's my lower limit. I started with position number 1, I'm ending with position number 75. So I need to find out, when I add 75 numbers together, what that is. Now, this is where things get a little bit more tricky if you don't know your formulas, but if you don't know your formulas, you're still going to be okay. This is your lower limit. In this case, because we have 1, this is a sub 1. This is your upper limit. This is your a sub 75. This is where it starts. This is where it ends. So for your initial number, a sub 1, you can identify this from your formula. For a sub n, or in this case, a sub 75, you have to solve for it. There's no other way for you to figure it out. You have to plug and check. So where do we find out the a sub 1? A sub 1 comes from the formula. If you look, you notice that this is your explicit rule for the arithmetic sequence when you start at 1. Since we are starting at 1, we're doing a happy dance. And this right here is your a sub 1. Where do we get this? We get this from our formula. Go back and rewatch that video if you're not sure where this came from. This comes from our formula. I'll actually do this for you guys here. I don't know if I'm going to have space. I'll do this. Thinking bubble. This is the formula. A sub 1 plus n minus 1 times d. So the common difference is 5. A sub 1 is 3. Comes from the formula. Anyways, so now that we have a s of 75 is equal to 75 divided by 2 times 3 plus, we still don't know what a sub 75 is. That is where you're going to do another thinking bubble. I'm going to do one up here since I have a little bit of space. And do a sub 75. And I'm going to use the arithmetic, so this formula here, to find what the 75th term is. So the number in the 75th position. We already know that the formula is n minus 1 plus 5. So n, we said we wanted in the 75th position. And the common difference is 5. Make sure that you are switching out your n's for the term that you want to know. 75 minus 1, that is 74. So I have 5 times 74. Need my trusty calculator for that. 5 times 74, that is 370 plus 3. So in the 75th position, I have 373. Now, again, this is not the answer. You're taking that 373 and plugging it in here. So when I add up 75 numbers together, what was it, 373? This is my formula for that. My recommendation is do not divide if you have a weird looking fraction like this. 75 divided by 2 does not give you anything pretty. Wait and divide diagonally, because this most likely will be an even number, and if it isn't, this will work out. So I have 376, so I'm going to do 376 divided by 2 first. So I have 75 times 188, and 75 times 188 gives me 14,100. So when I add up 75 numbers in this series, it gives me 14,100. All right, beautiful people. Let me see if we have any more. Oh, we have one more example. What is the summation notation for these series? Oh, let's do this one. This one's not going to take too much time. All right, this one here is asking for summation notation. Summation notation is sigma notation. Capital sigma. So again, we want our upper limit, our lower limit. We want our variable. You can choose whatever variable you want, and we want our equation. So this is a sub 1. We don't know what this is. This is a sub n. We don't know what that is. We know that the lower limit is going to be 1 because that's the position number is 1. However, we don't know what the upper is. We also don't know the equation, so maybe we can figure stuff out. We can, however, find out what the common difference is. So from negative 14 to negative 19, I am adding, oh, that's wrong, 5. I am adding 5 each time. Negative 14 plus 5, double check that, and it's negative 9. So a sub n, I'm doing my equation, my sequence, my arithmetic sequence equations first. A sub n is equal to a sub 1 plus n minus 1 times my common difference. A sub n is then equal to a sub 1. What is a sub 1? Negative 19 plus, we still don't know, n minus 1. Common difference we said was 5. So I have a sub n is equal to negative 19 plus 5n minus 5. Now it's your choice because they didn't tell you, to simplify or anything. You can put this as your equation. So I'm going to do that right now. Here's your summation. I'm going to put n as my variable. So n is going to be down at the bottom. Our lower limit is 1. Position number is 1. Then we have our formula, which is negative 19 plus n minus 5. Excuse me, n minus 1 times 5. You can simplify this. Absolutely 100% you can simplify this. Negative 19 minus 5, that is negative 24. You can do that. So I'll put an or here. Still the same formula, we just simplified it. Okay, we still need to find out what our upper limit is. And that's it. That's pretty much we're done. So upper limit, we do know that the last number is 226. However, we don't know what position number that is in. So what I'm going to do is I'm going to take this formula, and a sub n is 226. I don't know what my position number is. This is still unknown. And I'm going to solve it this way. So I'm going to add 24 to both sides. And I have 226, that should be a plus 24, that is 250 divided by 5. So n is equal to 50. So in the 50th position, the 50th number is 226. So my upper limit is 50. So either this one or this one, because it didn't tell you to simplify the equation. It's up to you. All right, beautiful people, this wraps up this video on arithmetic finite series. I hope you enjoyed it, and I will see you in my next video. Bye!